All right, students, I'm going to review our Mod 1 first unit test, the review packet itself, so that that'll help you be better prepared for this interim test, interim geometry test that the higher ups have made that you're going to be taking on Wednesday. So go ahead and watch this either Monday night, Tuesday night, or during the EL on Tuesday, the hour and a half EL after you watch the video reviewing for your quiz. That'll be Tuesday. All right, so number one here. Construct an equilateral triangle from the following segment. Remember, we put this pointer here, pencil over here, draw an arc, turn around, pointer here, pencil here, draw an arc, and then that intersection, take your ruler, connecting to it, there you go. Equilateral triangle. You could put your hash marks on there if you want to. Now they're equilateral, showing it like that. Okay, number two, draw the following. Line AB, remember line? It has to have arrows on both ends. A and B have to be points on the line. Ray AB, I'm sorry, ray BA, that means the end point is B going through A forever. Remember that you cannot have it starting at A and going through B forever. Ray, the order matters. Segment AB, those are the end points, and then connect in between. What does just AB mean? Remember, there's nothing about it. It means distance from A to B. How to bisect an angle. This is always on the DCAS, so good chance you might see that here. Arranging these steps of an angle bisector. That could be easily a problem. Remember, the first thing you do is pointer, move it out a comfortable distance, draw an arc, okay? From that arc, move it over more than halfway. You can go all the way to the other end. That way, if your compass moved, you know to put it right back here. You can go to that same way on the other side, but more than halfway, draw an arc in the interior. Okay, remember this is interior, inside the angle, not exterior. Draw an arc in the interior, turn around, pointer here, pencil on the other end or the same distance you had it before. Draw an arc on the interior, that intersection. Then draw your ray from the vertex to that intersection point, and there's your angle bisector. Now remember, we talked about what it established. That first arc that established that this segment is equal to this segment. When we open it more than halfway and did this arc and this arc, that established that this segment from here to here is equal to from this segment to this segment. And then thirdly, the last thing established is that this segment, after drawing the angle bisector, this segment from here to here is congruent to itself. And then you'd be able to prove that these two triangles were congruent by SSS. Okay? And therefore, then these angles, which are corresponding angles, are congruent by CPCTC. Now that you know how to prove triangles congruent, you can now see why it's SSS. I couldn't explain to you that before because we haven't been taught that. And now you know CPCTC, corresponding parts of congruent triangles are congruent. And so after proving congruent by SSS, you now have these two corresponding angles congruent by CPCTC. Remember, CPCTC is only used after proving triangles congruent. And then here was just another one to practice. Number four, perpendicular bisector. Put the pointer on one end, pencil more than halfway. You can go all the way to the other end, as I did here. Draw an arc, semicircle. So it's going to go all the way through on both ends. Turn around, pencil arc here, a pointer here, pencil over here, draw another semicircle, connect the two intersection points, and that's a perpendicular bisector. Now, notice the question underneath it. What is true about all points on the perpendicular bisector? So this is a common question that's always on the DCAS. You may see it on your interim test as well here. Okay, any point on this perpendicular bisector is equidistant to the endpoints here. So if I pick this point, that distance is equal to that distance. If I pick this point, that distance is equal to that distance. So it's any point on the perpendicular bisector is equidistant to the endpoints of the segment. Know that. Okay. Number six, when three or more lines intersect at a single point, they are concurrent. The other way you might see it written is concurrency, a point of concurrency. The circumcenter is constructed from the three perpendicular bisectors of the triangle. Remember, that means the point of concurrency, if I put a pointer there and a pencil on one of the vertices, it would create a circle around that triangle. The incenter is constructed from three angle bisectors. So doing this, if I have a triangle, doing this three times, three angle bisectors, intersect in what's called the incenter, and that creates a circle inside of that triangle that touches each side of that triangle exactly once only. Number 9, construct a perpendicular to the line below. So here we had to point off the line. I open it up, the pointer here, pencil a little past the line, draw an arc to get my 2 points I need. Then from there, open it up more than halfway. You can go all the way to the other end, draw an arc down here, turn around, point on this end, draw the arc down here, and then connect that point with that intersection point, and you have a perpendicular to the line. Remember, this is not a perpendicular bisector because the line goes on forever, just perpendicular. All right, number 10, we have a linear pair. Remember, linear pair are two adjacent angles that are form a line. That's why you have the word linear, line, in there. And it's a pair, only 2 angles, not more than 2, not 1. It has to be 2 exactly. And then there's supplementary. Remember, all angles that are supplementary add to 180. So 144 from 180 is 36. Number 10, all these angles combined here create a circle. We know a circle is 360 degrees. So you set up our equation, 1g, 2g, 3g's plus 273 equals 360. Subtract the 273 across, divide by 3, and I get 29. Over here, multiple ways, we have a vertical angle we have right here. Okay, so those are the same. I have a vertical angle right here. So these are the same. Now I also have a line. These 3 angles, this angle plus this angle plus this angle, add to 180 degrees. It forms a line. It's not a linear pair because it's not 2 angles, it's 3. But it forms a line, so it's 180 degrees. So that plus that adds a 380. I mean, sorry, 180. Okay, and that's what I have written up here. And then we solved it. Combine like terms, solve it. Okay, because x is 27. Then I can plug that 27 in there, the 27 in there, and that 55 is a vertical angle. 27 there makes this 34, and then we know that these 4 angles add to 180. Okay, so we can add those up. Right down here adds to 180, forms a straight angle. Our straight angle is 180 degrees. Okay, and then we can solve, combine like terms, solve for y, and y is 47. Linear pairs are supplementary. Remember, they're also adjacent as well, and they add to 180 because that's what supplementary means. All adjacent angles that form a line add to 180. So here we have adjacent angles that form a line, so they add to 180. Two angles that add to 90, complementary, and isosceles triangle. If you have an isosceles triangle, so let's go ahead and quickly create one right here. I have an isosceles triangle. That means that these 2 sides are congruent. If I have an isosceles triangle, let's go ahead and put in a 50 degrees in there, for example. Or this one's called the vertex angle up here. Just vocab-wise, where the 2 sides intersect or come together for the angle, that's the vertex angle right there. I'll go ahead and write that in there for you. Just review your vocab. Vertex angle. Okay, and so if I have an isosceles triangle, that means the base angles are equal in measure. So I could put an x here and an x here. Okay, so remember, all triangles add up to 180 degrees. So now I'd have 50 plus 2x equals 180. And I just solve that, subtract the 50 across, I get 2x equals 130, and divide by 2 on both sides, and I get x equals 65. Okay, you're bound to see that, whether it's on the interim test or the DCAS itself. You'll always have isosceles triangles in there. Make sure you know this. Exterior angle theorem. Exterior angle of a triangle equals the sum of the 2 remote interior angles of that triangle. It's just a vocab question. Remote, also, remember, it'll have the word either remote or opposite interior angles, one of the 2. Okay, it just depends on the book. Remote or opposite interior angles. I think we'll see that on the next page. Okay, an example of it where you actually do solve it. This is just the vocab part. All right, given a pair of parallel lines cut by transversal, name our 4 types of angles. I have that on top of the next page. Let's see if you can name them right now before I flip to the next page. We have corresponding angles are congruent. Same side interior angles are supplementary. We'll get to these down here when we're actually naming them. Alternate interior angles are congruent and alternate exterior angles are congruent. Remember, the word alternate means diagonal. Interior is inside the parallel lines. Exterior outside the parallel lines. Remember, the only one that is supplementary are the ones that have the S's in them already. Same side interior. Remember, the worksheet we worked on, they call them consecutive interior. So consecutive interior or same side interior angles, same thing. All right, the consecutive interior. If I can type it, get my fingers on the right. Dang it, get the fingers on the right here. Consecutive interior. That's the other way of saying same side interior. Consecutive interior. Um, that's the only one. The reason I like same side interior because it goes along with the S here, supplementary. Okay. All right. Name theorems that you can use to prove lines parallel. Remember, if you're proving lines parallel, it has to start with converse of. Well, and then in the worksheet we use, they put converse at the end. It's got to have the word converse in it. Okay. Just know that if you're ever proving lines, they will have them multiple choice. They'll have them without it, and they'll have some with them. You need to know. You wipe out any of them that don't have the word converse in it whenever you're trying to prove parallel or lines are parallel. And then it's just these same four that we have up here. So if we can show alternate interior angles are equal, then the lines are parallel by converse of the alternate interior angles. If we show alternate exterior angles are equal, then we prove it parallel by converse of the alternate exterior angles theorem. If we show corresponding angles are congruent, then it's converse of the corresponding angles postulate. And if we can show consecutive interior angles or same side interior angles are supplementary, remember that means they add to 180, then they're parallel by converse of the SSI theorem. All right, so let's go ahead and name the angles. Name all the angles are equal in measure. Well, we know vertical angles are equal, right there, A and D. D and E are alternate interior angles, so they're equal. And E and H are equal, vertical angle theorem. Okay, B and C are equal by vertical angle theorem, then C and F are congruent by alternate interior angles, and F and G are equal by vertical angle theorem. That's not the only way you can get to them, but that's just a quick diagonals, cutting through like this. Okay, from the name all the linear pairs. One linear pair, remember, two adjacent angles that form a line. So there's one, 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 and there's one. That's all the pairs. Name the same side interior angles. Remember, interior, I can only choose from C, D, and F, and same side of this transversal, or it's called transversal. So C and E is one pair that are supplementary that would need to be added to 180 if they're going to be parallel, and D plus F would have to be adding to 180 supplementary if they're going to be parallel. Name the vertical angles. Where you did that, BC, AD, FG, and EH. Name the corresponding angles. That's A and E, C and G, B and F, and D and H. Corresponding of one interior, one exterior, but they cannot be adjacent. Okay, and they are going to be on the same side of the transversal, nothing alternate. Remember, alternate means diagonal. Let's see, name the alternate interior. Again, we're only choosing from interior angles, so C and F. Alternate means diagonal. So C and F are congruent, D and E are congruent, because these are parallel lines already. Name the alternate exterior. Again, exterior, that means A, B, G, and H. Alternate diagonal, so A and H, B and G, and they are congruent. Solve for the variable. Remember, we extended this segment right here. Okay, and then we drew an auxiliary line. This is called an auxiliary line. Okay, just remember the name right there. That's called an auxiliary line. Okay, we drew that in there. That was not there. Auxiliary line. Okay, or line segment if you want to say, because we actually didn't put arrows on it, so it's really a line segment. But if they ever ask what is that called, it's called an auxiliary line. Okay, that'll just be a vocab question. So we did that, and then we have a linear pair as a result there, and this auxiliary line is parallel to the already parallel lines, and so we have alternate interior angles are equal right there. We have alternate interior angles are equal right there. This when we extended this forms a linear pair, and then we have alternate interior angles here, and then we can just add these two together. 18 plus 82 is 100. Solve for the variables. Okay, here's where we can use remote interior exterior angle theorem if we wanted to. We notice we have these are parallel. So first thing I'm looking for is parallel lines cut by transversal is alternate interior angles. That's the first one I'm always looking for. Even with triangles, we're doing triangle proofs. Same thing. Don't forget it. So 46 and 46. Well, then we have two of the three. We can add those together, subtract from 180, and get that one. Okay. And I could look at this one here, 92 and 92. Those are alternate interior angles. Parallel lines cut by this transversal. Alternate interior angles are equal. So that's 92, or I could have got it from doing 46 was 42, subtracting that from 180 to get the 92, because remember all three of these adjacent angles form a line 180 degrees. I could have used the exterior angle theorem, which would say that this equals, oh no, I don't have the exterior. I didn't do an exterior angle on this one here. This is not an exterior angle, so I can't use that there. I'd have to have drawn it out here, for example. Then this angle would equal that angle plus this angle. So that angle up here, if I extended that out, would be 88 degrees right there, which makes sense because 92 and 88 is 180 for a linear pair. All right, here's our exterior angle theorem, as I have written right here. The exterior angle, extend out one of the sides, equals the sum of the two remote interior angles. So it's these two remote interior angles added together. Let's try drawing a better plus sign than that. Plus, there we go. So the exterior angle equals the sum of the two remote interior angles or two opposite interior angles. You never include the adjacent angle. Okay. So this 10x minus 20 equals 9x minus 5. Okay. Subtract the 9x across, 1x, add the 20 across, and you get 15. And that's all they want you to do, solve for the variable. Make sure you always read the question and see if they want you to go ahead and find one of the angles and plug that 15 back in. I always go back and read the questions. A lot of you made mistakes on it before. Okay, here we have a proof. Okay, with the exterior angle theorem. We know the exterior angle theorem says W equals X plus Z. But they want it, instead of X plus Z, they want it to be Y plus Z. Well, the reason we can quickly substitute that is because we know Y equals X by vertical angle theorem. Measure of angle X equals measure of angle Y, vertical angle theorem. So now I can go ahead and say the measure of angle W equals the measure of angle Y plus Z by substitution. I'm substituting in the Y for the X. Okay, next. This one we have a bunch of parallel lines. Okay, we're starting with this 65 degrees here. I could do alternate interior angles if I wanted to, or corresponding angles, and this forms a linear pair for 115. This gives you 115 by linear pair theorem or alternate exterior angles. Okay, then this one and this parallel, these are same side interior angles, so that means they're supplementary. 115 plus 65, or I could have done corresponding. This 65 corresponds with this one for the 65. I then have a linear pair here for 115. Okay, this 157 here makes a linear pair for 23. This is 88 here, that makes this 88 vertical angle theorem. Okay, this already is 90, so I have 90 plus 88 plus 115 plus angle C adds a 360. I have a quadrilateral. Remember, all quadrilaterals, convex quadrilaterals, add to 360. So I have 3 of the 4 right there. Okay, which is these 3 right here. Subtract it from 360, and I get 67 there. Coming over here, I have 56 for the vertical angle theorem. I have 2 of the 3. Then I can add those together, subtract from 180, and I get 101. I also have linear pair theorem there for 124. So this is 101. Corresponding angle right here is 101. Linear pair, supplementary, so that's 79. Corresponding there is 79. Corresponding there is 79. Linear pair there, 101. There you go. All right, identify each as true or false. Angles 1 and 5 are adjacent. Are they right next to each other, connected by sharing the same side? Yes, they are. 3 and 5 are vertical angles. These are not vertical angles because it would have to be this line coming through here to be vertical angles. This one does go through. That one works, but this one does not. The vertical angles we have here be 2 and 4. Notice that forms a line and that forms a line. Vertical angles. 3 and 4 are complementary. 3 and 4 are not complementary. They are supplementary. They form a linear pair. They're supplementary. And 1 and 2 are supplementary. No, 1 and 2 are not supplementary. They are complementary. They add to 90 degrees with our right angle symbol right there. Okay. 33. Name an angle supplementary to AOD. AOD right here. Remember, supplementary means it's going to form a linear pair. So that one plus AOB forms a linear pair. Adjacent and congruent to AOE. AOE I mean, sorry, here's A. AOE is 90 degrees. What's the other one that's 90 degrees? This one right over here. COE. It's got to be congruent as well. Not only adjacent, but congruent. Supplementary to EOA. EOA, that's 90 degrees. We want it to be supplementary, so that's going to be, again, EOC. Okay? It's got to form a line. And so that's 90. Here's my other 90, and they form a line. Well, that doesn't have to form a line. Sorry, it just has to add to 180 for supplementary. That's all it's asking. Complementary to EOD. EOD, the complementary one. Well, we know this whole one, EOC, is 90, so complementary to this one is COD or DOC. Okay, right here, 30 degrees. A pair of vertical angles, or they have to form two lines. There are two lines, so here's our vertical angles right here, AOB and COD. All right, in algebra it says ray GH bisects angle FGI. Okay, solve for X. I didn't actually draw it out there. It says GH, so it has to be G. Point on here would be H, G, and H. As it says, bisects FGI. Well, there's a G, so I need an F, point F on here somewhere, and point I. So put the F right, oops, F and I. There are always capital letters for points, never lowercase. Lowercase are used for side lengths. Okay, the bisect it. Solve for X to find the measuring angle FGI. Where X? Am I missing something? Is it drawn up here? Oh, it's up here. I was like, we're missing information here. All right, no wonder it's drawn up here. Okay, so this bisect, I mean, these are equal. You see one arc and one arc. So 3x minus 3 equals 4x minus 14. Solve it. X equals 11. That was solving for X. Find the two measures. Obviously, they're congruent. They bisect it. So those two angles are congruent. Plug in the 11. 33 minus 3 is 30. So this has to be 30, which you get from 44 minus 14 is also 30. Okay. Here we have they form a linear pair. These two form a linear pair, which means they add to 180. So just add them together. Get this, combine like terms, that equal to 180, solve it. X equals 19.5. Then it says find the two angles. So take that 19.5 and plug it back into both of those. And you get 43 and 137. For what value of X is D parallel to E? So I have to look at what kind of angles these are to one another. These are same side interior angles, which is here the word S. So we know they must be supplementary. So 7x plus 3 and 2x minus 3 have to add to 180. Combine like terms, you get x equals 20. And then remember, if it asks what's the justification for that now, since I'm trying to prove lines parallel, it's going to be converse of the same side interior angles theorem. All right, which statement proves A is parallel to B? Okay, is 8 and 12? No, 8 and 12 are touching lines X and Y. We want them touching both A and B. 1 and 6 are vertical angles. I can't use that. Remember, it's going to be one of our 4 types. Vertical angle is not one of the 4 types. 5 and 13 are touching both the X and Y, not the A and B. 10 and 11. 10 and 11, they're both touching lines A and B. And those are same side interior angles. So if these were supplementary, they would be congruent by the converse of the same side interior angles theorem. What makes it X parallel to Y? Okay, so we got to touch X and Y. 2 and 3. 2 and 3 are touching A and B. 12 and 13. 12 and 13 are touching A and B again. 14 and 15. 14 and 15 are touching A and B again. 6 and 9 though. 6 is touching X, 9 is touching Y. So it's 6 and 9, and that'd be converse of the alternate interior angles theorem. They're alternate interior angles right there. All right, 39. Okay, we have two triangles connected here. Again, this is 104, 22, 19. Solve for X, Y, and Z. Well, we have two of these three. So we can go ahead and solve for the third one there because all triangles add to 180, you get 54. These two form a linear pair, so 180 minus 54 is 126. Now we have these two, we can add those together. 126 and 119 is 145. From 180 makes it 35 for Z. Okay, and I said what the theorems were. Triangle sum theorem for the first one, linear pair theorem for the second one, and again going back to triangle sum theorem for the third one. All right, 40, last page here, I believe. Okay, again, we know the three angles of a triangle add up to 180. So we add all the angles together. It's a mixed number, change it to improper fraction, multiply by the reciprocal, and you get S is 140. 140, then plug those in there. 73, or 23, and 40, 20 minus 13, 3 is 17. Didn't ask you to find that, just asked you to find S though. All right, if G is parallel to H and the measure angle 2 is 88, what's the measure angle 3? Well, if these two are parallel, we know corresponding angles are parallel. Corresponding angles postulate or theorem, and these form a linear pair. So we have 92 degrees, the linear pair theorem. If V and W are parallel and the measure angle 1 is 120 right here, what's the measure angle 2? Well, I can go here to here for alternate exterior angles, that'd be 120, and then linear pair to get 60. I could go 120 to 120 right here for corresponding, and then these are linear pair for 60 degrees. All right, what are the measures of angle EBG? EBG. Okay, I look at either both the outside numbers and subtract them, bigger minus smaller, or the two inside numbers and subtract them, bigger minus smaller. So we have 100 minus 65 is 45. And then classify it. 45 degrees would be acute. Okay, and EBC. EBC, we can see that's more than 90. There's our 90. EBC is 100 degrees. Starting at 0, going up to 100, and that's an obtuse angle. Name the numbered angle in 3 different ways. So we already have angle 2 is one way to name it, angle DBE, and EBD. Remember, the vertex must be the middle letter, and again, all capital letters. All right, and that does our end of our review. So that should be a helpful reminder to help you out for the park. Don't forget to know, you also need to know your 5 ways of proving triangles congruent. SSS, SAS, ASA, AAS, and HL. Remember, HL is hypotenuse leg. Okay, so look over those worksheets because that's something we haven't covered in the review here. So you will see angle congruence. Remember how to name corresponding sides correctly, corresponding angles correctly. That will be on your interim here as well as on your unit test. So there we go. Review this as well, and hopefully you do your best on the interim on Wednesday.